Now, that raises a problem. Okay, I'm gonna write down these requirements, but how do I know that those requirements are actually going to get me what I want? Well, what I did to ensure that it kind of works out the way I hope is the very first thing I did is break down the project into modules, okay? So I created a diagram of the system that we're planning to create, a very basic like flowchart, very basic flowchart diagram. And it basically just had a bunch of modules connected to other modules. And there's about 9 modules. And I said, okay, there's these 9 modules. And that's, you know, that breaks it down a little bit. You always want to break down your problems, okay? That's a very important thing in all of business, to break down your problems. I just sit and think about this module, and I just write down as very best as I can, okay, well, it should do this, it should do that, it should do that, should do this. We should be able to influence it in this way. We should be able to make changes in that way. And what I'm looking for is I'm looking for 3 types of requirements. I'm looking for requirements of structure. And that means like this thing exists. It's like this component exists. It's here. This thing of this type is there. And it goes there. I'm looking for requirements of function. So now I can say, okay, I've got a component. So what does it do? I want this particular thing to do that. Or I want this particular person to be able to do that to this thing. I want this thing to interface with this thing over here. I want it to do some function. And then the third type of requirement I'm looking for is a requirement of performance. So, okay, so it functions this, it achieves this, but how well does it do it? How easy is it? How fast is it? How long does it take? How many, you know, you can think of like, oh, how many centimeters? How many minutes? How many, and you can think of all the different units, or like, how well does it perform, right? So I'm looking for requirements of structure. It's just like, this is this. Requirements of function and requirements of performance. Now, after you have written down a bunch of requirements, you have to then look at them and think about why they're terrible. Because if you don't go through the phase of like looking at what you've done and thinking, why is what I've done terrible and useless and it's going to turn out horribly, then you're just going to go, hey, that's good, tick. And you're going to pass it off to someone else and it's going to come back bad. So I looked through all the requirements and I just tried to figure out every single thing that was bad about them. I'm like, oh, what's bad about this? And I just wrote down all these notes. It's bad for this reason, it's bad for that reason, it's bad for this reason, it's bad for that reason. And then I looked at all the different reasons that I wrote down. And I thought, what are the common themes about these reasons? Because if I can figure out the common things that are bad, that can potentially be bad about requirements, then I can easily look at any requirement that I write and like in a snap, I can know what's bad about it and how to change it. And what I come up with was these 5 words that I can look at requirements and decide why they're not good. And I gave it a simple little acronym, which I believe is MUWIC. M-U-W-I-C. Okay? So there's 5 reasons when you write a requirement that it can be bad. Okay, so first, misleading. If a requirement that you put together is misleading, you're in trouble. Because you write it down, someone else will read it, and then they'll go, ah yeah, I get it. And then they'll go do the wrong thing. And then they'll come back and say, I did it. And you'll say, but that's not what I wanted. And they'll point to the requirement and say, yeah, this is what you wanted. See? And you'll go, oh no. No, I actually wanted this. And they'll say, well, that's misleading. So if one of your requirements, how you tell people to do your project, is misleading, whoosh, you got to change it. The next, okay, remember, MUWIC. U is undefined. If you refer to something in a requirement, some object, some person, something, anything, if you refer to it in the requirement and you haven't defined it like in a glossary or nomenclature or something like that, and then you just want people to know about it, no good, no good. Okay, so if it's misleading, no good. If something is undefined, no good. The next thing is if the requirement is weak. So if the requirement uses words like, oh, this thing can do that, this thing might do that, this thing may do that, this thing could do that, or it's not, or in some other way, it's not really forcing the system to have something or do something or perform to a certain degree of quality, then your requirement's weak. It can be ticked off without actually being met. And people can go, yeah, I mean, yeah, it can, this is good, or yeah, it's good. So if you can sense that the requirement's not really going to lead to what you want just because the requirement isn't, strong enough, bad news. Infeasible. If the requirement's not feasible, if someone's going to look at it and go, well, how can I possibly do that? Then no good, okay? That's a simple one, infeasible. And the last one is confusing. So if your requirement is some way vague, ambiguous, or just the way it reads, someone's like, I don't get it, then bad. Now that's different from misleading. There's a difference between misleading and confusing. Because in misleading, they're like, oh yeah, I get it. They go do the wrong thing. It's right. It's the right thing according to how you've written it, but it's not the wrong thing. And confusing, they actually come to it and they're like, I don't know. I'm going to need to clarify this. I'm going to need to talk to someone. So remember, MUWIC, M, misleading. U, undefined. W, weak. I, infeasible. C, confusing. So you go through your second draft of these requirements and you make sure that they're all conforming or like living up to your expectations of those 5 things, MUWIC. Now, the next thing, the final thing, the third thing, I think we're up to 3, is your requirements have to be verifiable. Because if your requirements are not verifiable in some particular way, then you don't know. Like, have we met the requirement or not? I don't know. Well, let's just pass it off to the next team anyway. And well, I hope it's good enough. So that's going to leave you in situations like that. And you come to this thing as like, is this done? I don't know. Have we finished? Is this good enough? I don't know. Like, is it going to be good enough? And you ask everyone and no one knows. And it's like, well, I don't know. And then you're in the situation where, oh, maybe your project's going to fail. Don't know. Maybe it's not going to live up to some expectations. Maybe it's not going to give the stakeholders what they needed. So you have to have requirements that are verifiable. Now, there are 4 methods, standard methods of verifying requirements. They are inspection, demonstration, test, and analysis. I will read those out to you and what they mean. This is a standard kind of engineering definition that I'm going to give you. So, inspection. The non-destructive examination of a product or system using one or more of the 5 senses: visual, auditory, olfactory, tactile, taste. It may include physical manipulation and measurements. Demonstration. The manipulation of the product or system as it is intended to be used to verify that the results are as planned or expected. Test. The verification of a product or system using a controlled and predefined series of inputs, data, or stimuli to ensure that the product or system will produce a very specific and predefined output as specified by the requirements. Analysis. The verification of a product or system using models, calculation, and testing equipment. Analysis allows someone to make predictive statements about the typical performance of a product or system based on the confirmed test results of a sample. Okay, so you have to make sure that there's some particular way. So you write your requirements, you write them well so they conform to MUWIC. They're not misleading, they're not infeasible, they're not undefined, they're not weak, they're not infeasible, they're not confusing. And then you denote next to them, is this a functional requirement, a structural requirement, or is this a performance requirement? And then you also write down, are we going to verify this by inspection, demonstration, test, or analysis? Okay, now you've got a pretty sweet bunch of requirements going. Now, of course, you're going to have to go back and forth with someone else and just check, is this what you're talking about? Are these good? Do you think they're well written? Is this going to get what we're looking for? Ask a few people, like ask the random person who works in support, like, what do you think of this? Does this make sense to you? Ask a whole bunch of different people, because this phase, even though it's like dreary and blah, 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 it's super important. It's the most important phase of the whole project. So that's how to do requirements engineering in a very basic way, at least the first phase. Hope that was useful to you, and I'll see you next time.